Apply. In the silence of the night, where the stars paint their eternal story across the heavens, lies a cosmic riddle so powerful, so terrifying. Apply. It bends not just space, but even time itself. For centuries, humanity dared to wonder what lurks in the shadows of the universe. Today, apply, we follow the footsteps of brilliant black scientists who dared to seek the answer. And at the very heart of their journey, black holes apply, the most mysterious and unstoppable forces ever known. Imagine a place where light itself cannot escape, where gravity is so fierce, apply, reality twists into something almost unimaginable. From theories once dismissed as madness, apply, to groundbreaking discoveries now shaping the very fabric of astrophysics. This is not just science, this is the story of courage, vision, and truth written among the stars. Apply. When we think of endings, we imagine silence of finality. But in the cosmos, endings are not just finales, they are rebirths into something far more extraordinary. Apply. A black hole is not born quietly. It is forged in the fairy death of a star so massive, so powerful, that it can no longer carry the weight of its own existence. For millions, apply, sometimes billions of years, these giants live, burning hydrogen into helium, fueling the light that reaches across galaxies. But every star has a limit. Apply, a breaking point written in its DNA. When that time arrives, the star collapses under its own gravity, pulling everything inward in a catastrophic implosion. Apply. This collapse is no ordinary fall, it is a violent event of unimaginable scale. The outer layers of the star explode outward in what we call a supernova. Apply. One of the most powerful displays in the universe, so bright it can outshine an entire galaxy for a brief, fleeting moment. But while the explosion dazzles the cosmos, apply, what's left behind is even more haunting. The core of the star contracts further and further, squeezing down into an infinitely dense point, something physicists call a singularity. Apply. Imagine all the mass of a star tens of times larger than our sun being crushed into a region smaller than a grain of sand. At that point, the rules of physics as we know them break down. Apply. This is the birth of a black hole, a region of space where gravity is so intense that nothing, not planets, not radiation, not even light itself, can escape its grip. To put it simply, apply. A black hole is gravity taken to the ultimate extreme. And here lies the true wonder. From the ashes of a dying star comes not emptiness, but a new kind of celestial entity. Apply. One that defies our intuition, challenges our equations, and dares scientists to rethink the very fabric of the universe. For decades, apply, black holes were thought to be only mathematical curiosities, strange predictions in Einstein's theory of general relativity. Even Einstein himself doubted they could truly exist. Apply. But time and science proved otherwise. Observations of collapsed stars, the strange motions of objects orbiting invisible centers, and finally, apply, the detection of gravitational waves, all confirm that black holes are not just real, they are abundant, scattered across the galaxies like hidden gateways into the unknown. And so, apply, every black hole begins with a star, one that burns gloriously until it can no longer resist its own weight. Its death is violent, yet its legacy is eternal. In that collapse, apply, the universe does something both destructive and creative. It erases a star, and in the same breath writes a new chapter in the story of existence. When we look at black holes, apply, we are not just peering into cosmic voids. We are witnessing the aftermath of stellar life, the transformation of brilliance into shadow, and the breathtaking reminder that in space, apply, even death is never the end. The boundary of a black hole is unlike anything else in the universe, a frontier so absolute it defies imagination. Apply. This invisible perimeter is known as the event horizon, and it represents the point of no return. To grasp its power, imagine sailing toward a waterfall in a river from far away. Apply. The water seems calm, flowing gently, giving little hint of the danger ahead. But the closer you get, the faster the current pulls you, until at some point there's no turning back. Apply. No matter how strong you paddle, no matter how fast your engine, you are destined to plunge over the edge. The event horizon is that edge not of water, but of space itself. Apply. At this threshold, gravity is so overpowering that not even light, the fastest traveler in the universe, can escape. Once something crosses that boundary, be it a planet, a star, apply, or a beam of light, it is swallowed forever, its fate sealed within the darkness. What's striking is that nothing special would feel different as you pass the event horizon. Apply. There are no warning signs, no visible barriers, no flashing cosmic signal that says, beyond here you vanish. To an observer falling in, it would be a strangely quiet descent. Apply. But to anyone watching from the outside, that fall would appear frozen, stretched endlessly in time, as if the universe itself refuses to let go of the image of what is being consumed. Apply. This paradox, where time itself seems to behave differently, is one of the great puzzles that black holes force us to confront. For the object falling inward, Apply. The journey is swift. Once you cross the event horizon, you plunge toward the singularity at the heart of the black hole in a finite time. But for someone far away, apply. Your fall seems eternal. Your last signals of light stretch thinner and redder, fading into invisibility. It is as though the universe conspires to keep the boundary hidden. Apply. To protect the mystery within, scientists describe the event horizon as the ultimate one-way door. Nothing that enters can return, no signal can carry information back. Apply. This makes black holes terrifying, but also fascinating because they embody the very limits of what we can know. If the event horizon marks the edge of reality as we can measure it, apply, then what lies beyond remains speculation, an abyss where our physics may crumble or be reborn. Black holes come in many sizes. Apply. From those just a few times the mass of our sun to supermassive giants millions or even billions of times heavier, lurking at the centers of galaxies. Apply. Yet all of them share this defining trait, the event horizon, the surface of ultimate secrecy. We cannot peer inside, but the horizon itself tells us a story. Apply. It is a reminder that the universe has boundaries not made of walls or matter, but of rules written into the geometry of space-time. And when we look at that invisible edge, apply, we are staring at the line between what we can understand and what remains forever hidden. Time, as we know it on Earth, feels steady, reliable. Apply, ticking forward at the same rhythm no matter what we do. But near a black hole, time itself becomes distorted, stretched, and bent under the immense pull of gravity. Apply. Imagine standing beside a massive clock tower with two identical watches, one strapped to your wrist and the other hurled toward the edge of a black hole. From your safe distance, apply, you'd watch the second hand on that falling watch begin to slow tick by tick, dragging further apart until it nearly stops altogether. But for the watch itself, apply. For the one plunging closer to the black hole, nothing would seem unusual. Time would feel normal, seconds passing naturally. Apply. Even as the universe outside sees them stretched into infinity. This is the staggering reality predicted by Einstein's theory of general relativity. Apply. Gravity doesn't just tug on matter, it warps the very fabric of space and time. The stronger the gravity, the more time itself slows down. Near Earth, this effect is minuscule. Apply, detectable only by the most precise instruments. But near a black hole, where gravity is millions of times stronger, the effect is overwhelming to an observer far away. Apply, anything close to a black hole appears frozen in time, locked at the brink of the event horizon forever, teetering on the edge. This phenomenon is more than a strange curiosity. Apply, it reveals something profound about the nature of reality. If a person could venture close to a black hole and somehow return, apply, they would find the universe outside had raced far ahead of them. Hours for them might equal years, centuries, or even millennia for the rest of the cosmos. Black holes, in this sense, apply, are natural time machines, bending the flow of the universe in ways that challenge human understanding. Scientists call this gravitational time dilation. Apply, and it has inspired not only theories but also art, literature, and film. The idea that time itself is not fixed but relative sparks questions that ripple far beyond physics. Apply. What does it mean for our concept of existence if time can pass differently depending on where we stand in the cosmos? Black holes hold the most extreme answers to that question. Apply. Serving as laboratories where relativity itself is pushed to its breaking point. At the very edge, the event horizon, this slowing of time reaches an infinite stretch. From afar, apply. It looks as if nothing ever crosses the boundary, as if the universe conspires to hold objects in a state of eternal suspense. Yet for the traveler falling inward, apply, their journey continues swift and unstoppable. Two truths coexist, time frozen to the outside, time flowing normally to the inside, reminding us that reality is not absolute, apply, but relative to the eyes that witness it. In the crushing embrace of a black hole's gravity, time is no longer a universal clock. It is a flexible thread, apply, pulled and warped by cosmic weight, showing us that the cosmos does not play by the rules we grew up believing. It plays by deeper laws, mysterious, beautiful, apply, and still waiting to be fully understood. For centuries, the mystery of black holes belonged to theory, to mathematics scribbled on chalkboards, apply, to ideas so strange that even great minds hesitated to believe them. But as science advanced, apply, it was the boldness of visionaries, many of them black scientists, that helped transform these cosmic shadows from speculation into accepted reality. Apply. Their work was not just about equations or telescopes, it was about courage, about standing against barriers on Earth while peering into the deepest mysteries of the universe. Apply. One of those pioneers was Dr. Arthur B. Walker, an astrophysicist whose groundbreaking research into solar physics paved the way for the very technologies we use to observe black holes. Apply. His designs for X-ray and ultraviolet telescopes became the eyes humanity turned toward the heavens. Apply, capturing data that revealed the violent births of stars and the high-energy processes that hint at black holes. Without his innovations, apply, much of the evidence we now celebrate might have remained invisible. Then there is Neil deGrasse Tyson, a voice as much as a scientist. Apply, who made the wonders of black holes accessible to millions. Through his ability to bridge complex physics with everyday language, Apply, he helped inspire a generation of dreamers to look up at the night sky and wonder. Apply, his presence in the conversation of astrophysics is a reminder that science is not just about discovery, it is about storytelling. Apply, about making the mysteries of the cosmos belong to all of us. But the influence extends beyond famous names. Countless black researchers and students have contributed to astrophysics, Apply, gravitational wave studies, and space exploration projects that bring black holes into sharper focus. Apply, their contributions show that the search for understanding is not limited by geography or background. It is a shared human endeavor. Apply, one where diversity of thought and perspective brings new ways of questioning the unknown. In the darkness of a black hole, we see the reflection of something greater. Apply, the strength of human unity in pursuit of truth. When we talk about black holes, we are not only speaking of collapsed stars and infinite density, we are speaking of human determination. Apply, of scientists who dared to reach beyond limits both cosmic and earthly. The story of black holes is the story of people who refused to accept boundaries. Apply, who looked into the universe's most terrifying secrets and said, "We can understand this." Their work reminds us that science is not cold or distant, it is alive with human passion. Apply, human struggle and human triumph. And now, as telescopes capture the first images of black holes, as gravitational wave detectors listen to their cosmic echoes, Apply, we know this is just the beginning. Each discovery honors those who lit the path before us and inspires those yet to come. The universe is vast, mysterious, Apply, and waiting, and with every question we dare to ask, we take another step closer to knowing it. So if these journeys into the heart of the cosmos excite you, Apply. If these stories of courage and discovery spark wonder in your own heart, make sure to like this video, share it with others who dream of the stars. Apply and subscribe for more explorations into the universe's greatest mysteries, because together we'll keep reaching higher and further into the unknown.